Hello, this is Efrem Bonfiglioli, and I'm the lead solution engineer at ILTS. Today I want to take you through some key elements of the new ECB guidance on internal models. And although the guidance is specifically, indeed, as we just said, to internal models, actually there is specifically mentioned in the document about the need for a model risk management framework across all models. So we're going to spend some time going through a couple of videos together where I want to highlight some elements around the model risk management framework, specifically the register and a system that manages users of this register. Then in the second video, we're going to be focusing mostly on the guidance. It's a new chapter on guidance on the machine learning techniques that models may use and how the increased scrutiny is expected for this type of models. So a particular kind of focus there on the fact that machine learning model techniques are welcome, but again, there should be more diligent model validation and testing, especially with focus on explainability. So let's get started. In this video, we go through some key elements of the ECB regulatory guidance on internal models. So we focus on a couple of chapters. Chapter 2, where indeed there are information related to the models, or what content we need to store for models. And then chapter 4 focuses a bit more on the holistic model risk management framework that needs to be implemented. So let's indeed start from this part. First of all, a model risk management framework is required to identify, understand, manage model risk. That's a very important element. And as the note 15 says here, all models need to be included as part of this framework. We're going to be focusing on a couple of pillars. First one, which is highlighted in paragraph 6 of this document, is around the register or a model inventory for models. And then in paragraph 7, we look at requirements on documentation and access permission. Let's start then from paragraph 6, where, again, the need for a register is very clear, where lots of information needs to be captured. For example, weaknesses or limitations for models, and information whether the model is a third party belonging to a vendor. And in paragraph 7, we'll cover the requirements to store different type of documents in the inventory, as well as managing access permissions for different stakeholders. Let's go into the ILTS application. The ILTS application helps you indeed inventorize all the models and more, even different assets. And what we want to do is to show that essentially the inventory of the register is holistic across all types of models. As you can see, we have actuarial models, data preprocessing models, and of course, regulatory models such as PD models. And this is where I'm going to start from to go into more details. For PD models here, let's select a PD model for credit cards. What we want to have is to make sure we have a comprehensive set of information that can be immediately identified for a model. As you can notice, apart from lots of information on the models, we do identify whether the model is an internal model or a third-party vendor model. And of course, we also want to make sure that the vendor name is available immediately. Among the information that we require to store, according to the ECB guidance, is, as we mentioned, weaknesses or limitations. Limitations, of course, can be defined either specifically for one model, but typically they are common across models. That's why you want to add them from a list of taxonomy available already in the application. And just to show an example of one of them, limited coverage. Very important to manage model risk is to actually see also, obviously, description of the limitation, but also go into more details about what are the mitigants that are in place to offset some of the risk for this model. And here again, there are the mitigants so that the model risk manager can make an informed decision at what the residual risk for this model may be. Next thing to see, according to paragraph 6 of the guidance, was to show that also various types of documentation is stored in such an inventory. And again, as you can see here, for this model, we can collect obviously those documents into subfolders to easily find them, and also we have tags for different documents. But it's very important also to make sure that we have at each events of the life cycle, whether it be model development, model validation, or monitoring, different documents are gathered, and the application helps you either generate documents based on your own template or simply upload documents in case they are on a different structure. To conclude, I would like to show you that also users can be managed inside the application. So obviously this is available from the interface only to restricted amount type of users. In this case, I want to show you in the admin section how an example of a user, the CIB user, first of all is granted a series of kind of roles or one or multiple roles as based on what they have to perform as part of the model risk management framework, but also they typically have permissions. In this case, this user is a basic permission group that contains some business functionality, but also has some model owner type of kind of permissions attached to it. And also there's an additional element to define scope packages to delimit sort of the mandate around specific type of use cases or models. In this case, obviously, CIB users should only be allowed to see CIB relevant information in the inventory. And this is it for this video. In this video, we go through the ECB requirements on internal models, but with particular focus on machine learning techniques. This is chapter 9 of the document. So here we're going to highlight a couple of elements. There are plenty of details in the documentation here. Focus, of course, is here to understand, first of all, what do they define as a machine learning model. It's very clear, large number of parameters, high nonlinear functions, and large number of data. And then there is obviously the consideration about complexities versus explainability, which is very important, and we're going to cover this. But very important also is that it is stated very explicitly that a linear or logistic regression is not considered a machine learning technique. So for the focus for this video will be mostly on kind of the requirements specifically for ML models. So if you have basically at some point here it's mentioned very explicitly that if you're switching from a traditional model to and machine learning-based models, that's considered a material change. So you want to have a process that helps you track that particular kind of change. So basically, in the application, you will see this is called a major modification type of process. Why is that important? Because it also typically involves internal validation, and this is what this requirement, this guidance specifically mentioned, that internal validation will be required when there is a material change. As part of this, of course, we have specific requirements. What I want to focus for today is, of course, mostly on the testing, as I said, and I want to mention that there is quite some emphasis on explainability. So they do encourage users to use, of course, ML-based models, but they also want to make sure their models are explainable. So we're going to go through this. And towards the second part of this section, there is some important elements around the IT infrastructure. So this will be the infrastructure should be capable of supporting basic specific needs of machine learning models, again, data and complexity of the models. But very importantly, it should be a traceable solution that helps you basically track all the experiments, all the evidence around basically your life cycle for the model. So we're going to go to the ILTS application now. I'm going to start by showing you that indeed in the ILTS application you can make sure that the model is taken through kind of a material change of process. We call this major model modification in our default configuration. And again, in the beginning you can make sure that the user has put some description about the change. In this case, of course, we just said that we switched to a machine learning based model. And that's important is that in the actual process definition here, you have make sure that your stakeholders, your model validation team has a step here that they have to go through the validation before the model with the new change in terms of ML-based technique is put into production. So that's important to have the process to enable that. We focus for today, as you can see, one of the steps in this configuration is to perform data and model testing. Our focus will be on explainability for the machine learning models. So for this one, I'm going to switch to the other components, the ILTS for performance component, where again, I have one example of an analysis of explainability based on some synthetic dataset, a Titanic dataset, to highlight a couple of elements. First thing is that, of course, as part of your test setup, you will have components to do. Some will be parameters, but of course some will be to do with data. So because the way this is set up in the application, you can actually track all of this in a very reproducible manner. So every time new data comes in, new tests are run, this is basically stored and reproduced and can be reproduced. And finally, what I want to show you is an example of explainability report that can be created for a particular model. As you can see, as you run your test, you'll be able to produce charts and tables like this one. Again, this is a focus on explainability of a particular ML model. And then again, you have the feature importance analysis that you can run, the partial dependency plot, as you can see here. And of course, nice or very important analysis to help you kind of assess the explainability of the model, which is again what is required. Shapley values is one example. And then again, kind of the usual nice visuals are produced here. And this is it for this video.